Hello and welcome to my second sequential circuit video. This one's going to be on Mealy analysis. A Mealy circuit is, and that's what we're analyzing, the Mealy circuit. It's just a type of sequential circuit. And a Mealy circuit is just a sequential circuit that has its result be a result of previous inputs and current inputs. And contrastly, a Moore circuit is just a sequential circuit that's a result of just the previous inputs. And so that's what kind of differentiates the two, is that Mealy is current and previous, and Moore is just previous. And so in this one here, we'll go ahead and start off by showing the current circuit. This is the Mealy circuit. And I'll kind of explain how it works. So basically, this it has 4 different states. We can actually show that here. It has 4 different states, and then it has an input. And so when I say state, I just mean states of Q1 and Q0. And so if you look at this picture here, we have 4 different states called A, B, C, and D. Those are arbitrarily named. And we have these 2 slots here. On the left is Q1, and on the right is Q0. And everything outside of these bubbles is X. So, and by following these arrows, it'll tell us what the circuit is going to do on the next clock pulse. So if we have Q1 is equal to 0 and Q0 is equal to 0, and we have X is equal to 0, it tells us that our state of the Qs, or what the Qs are, is going to change. It's going to go from 0, 0 to 0, 1. If X stays 0, it'll change again. If X becomes 1, it'll go back. You look at this one, if X is 1, it'll go back to 0, 0. And if it's 0, it'll go on to D. And same here. If it's 0, it'll go on to, well, actually it'll complete the cycle, so it'll go on to A, and then if it's 1, it'll also go on to A. But the difference is that if it's 0, the circuit will return high. And so that will sort of complete that diagram there. And if we can go ahead and match it up with this circuit here, let's make X1 just to reset the circuit. So this is negatively it's triggered, so when this is low, this will be positive. And so we can start when it's high. Boom. Okay. So we'll start at that was 0, 0, and now it's 0, 1. Now it's 1, 0. And then it's 1, 1. And oh, you see, and it became positive there, and then it goes back to 0. And we can kind of observe it based on the diagram here. If this is at 1, 1 right now, and it was 0, so it became 1. It's kind of complicated. It's moving a little fast, but basically it matches up with this table. And I guess just to further show what we can do with it, we can wait till this is sort of halfway through the cycle. We can wait till this is 1 and this is 0. We'll be at C at that point. And then we can change that to 1. And we can show that it's going to go back to 0, 0. So it took that route right there at that clock pulse. And then it's just taking this, every single time this ticks, it's just taking this route right here over and over again. It's just going back to itself. So that's that. We could show how this kind of works. We'll describe the process of the sequential circuit analysis. So first we start off with just having the circuit itself. And when we do this analysis, we want to get equations for all of our inputs to these flip-flops. That's kind of what we're looking for. So in this one, we have 5 inputs. It's going to be this one, this one, this one, this one, and this one. This can be called J0 and K0. This is J1 and K1, and this is Z. And you can derive these equations by looking at these mini circuits here, as well as just sort of these direct inputs here. And so if we want to get J0, for example, well, it's just represented by x prime. So it would be J0 equals x prime, because, well, the input is simply xp here, which stands for x prime. If we want to get k0, well, it's just this plus 5 volts, so it's just 1 all the time. If we want to get J1, it is Q0 and X prime. Like, just that's it. It's Q0 and X prime. K1 is this here. You can derive that circuit. It's Q0 or X, and so on and so forth. And so, once you get those equations, and I can kind of show them on the screen here, then you can turn those equations into a table, a state table. And the way we make this table is that, well, we have our states, which are, whatever Q1 and Q0 are. So if it's 0, 0, then we call it A. If it's 0, 1, we call it B, and so on. And then for every state, there's 2 possible inputs of X. So that's why we have 8 different combinations of potential outputs, that is. And it's based on the present state and then whatever input is. And so we can then derive the flip-flop inputs based on the present state. And that's given by all these equations here. So say that we want to get J0, for example. Well, it's just whatever X is not. So if it's the complement of X. So we just go down and we just see this is all the complement of X. If we want to get J1, well, we see, well, it's Q0 and X prime. So it's Q0 and X prime, so it's 0, 1, which is 0 and 1, which is 0, 0 and 0, which is 1, 1 and 1, which is 1, and so on and so forth. And that's how we fill out everything here on this part. It's just following the equations and plugging in the corresponding binary values. And lastly, this is a little bit more complicated here, but we have the next state, which is going to be like what the next state is, or what the next clock pulse is going to be. And this is based off the JK flip-flop characteristic tables. So if we want to get what Q1 plus is, which is whatever the next state is going to be, well, we have to look at J1, K1, and then Q1. So J1 and K1, they represent the mode of the flip-flop. And then Q1 is like whatever the output currently is. So if we want to get what Q1 is, then we say, okay, well, J1 and K1, 0, 0 represents no change mode. And so whatever Q1 is going to be what Q1 plus is. 0, 1 is going to be set mode, or it's the one that returns 0. It's either set or reset. I believe it's actually reset. So it would be reset mode. And so whatever Q is, it doesn't matter. It's just going to return 0 every time. When it's 1, 1, that's toggle mode. So it'll just be the complement of whatever Q1 is. So it's going to be Q1. And this one, it's going back to reset mode, so it'll just be 0 regardless of what Q is. Let's see here. And yeah, that's it. So, and then so on and so forth. So this will be no change mode. This is Q1. It just won't change. This is in reset mode. It'll go to 0. This is in toggle mode. It'll go to 0. And this is in reset mode, so it'll go to 0. And you do the exact same thing for Q0 plus. You just, well, except you don't look at the K1 and J1, you look at J0 and K0, and then Q0. And so if we see that J0 and K0 are in toggle mode, well, it'll just be 1. Because this is 0. And then you do the exact same process down that chart. And so that's how you make that state diagram. Oh, I guess I'll just bring it up again. And then from there, we can create our state, or that's our state table, I guess. And then from there, we can get our state diagram. And in our state diagram, it just shows, let's see here. Oh, actually, we need to fill out what the state name is. I forgot to explain that part. So the state name is basically just, we just fill out whatever the state name is to whatever these Q1 plus and Q0 plus is. So in this one, we called 01B. So when this is 0, 1, it'll be B. In this one, we called A 0, 0. So in this one, anytime it's 0, 0, it'll be A. And so on and so forth for the rest of them. And so you can fill out that state name. And by using that state name, you can create this diagram here. So you take the initial state, and then you take the end state. You take the initial state, and then you see, well, whatever x is, we can say, okay, well, that's what's going to determine what the next state is. Because this represents the next state. So when we have 0, 0, and our x is 0, it goes to B. If we have 0, 0, and x is 1, it goes to A. If we have 0, 1, and x is 0, it'll go to C. And then A, and then D, and then A, and then A, and then A. And so you can have sort of carry that on and draw the arrows and stuff. And that's basically how it works. Oh, and then whenever there's whenever Z is 1, that's where it'll have that star right there. And so yeah, that is pretty much that. Let's see here. I discussed why this was a Mealy machine already. And then lastly, I'll just describe what a tunnel is. So contrary to what we've seen in all my previous videos, where all of my circuits have been connected through wires, entirely wires, we're using circuits, which is a feature in Logisim that basically lets you connect an output to what's called a tunnel, and then we can take that tunnel and we can connect that tunnel to anything else, and it will carry on whatever the current state of that wire is. So in this one we have X, we have this input X, and it's connected to this tunnel X. And so whatever X is, this tunnel X, if we connect that to anything, like it's just gonna, here, I can actually demonstrate it. Let's see here, tunnel. So right now this tunnel isn't doing anything because it's not named anything. But say that I wanted this, say that I named this tunnel X. Oh, there we go. Now it's just going to be whatever X is, because it's feeding in, that's what it's becoming here. So you see, whenever X is 0, this becomes 0, and whenever X is 1, this becomes 1. So basically it just allows you to carry over the value of wires without having to like connect them to the entire thing, the entire circuit, which is nice. It makes it so that you can clean up your circuit and make things a little bit more easy to read and really get down to the fundamental logic rather than worrying about, you know, carrying a wire from this end all the way to Kingdom Come and back. So it's a great way to make things simple, and it's an extremely useful feature in Logisim. And so yeah, I know that was a bit of a hard to understand video, but this is a fairly complex topic, so bear with me. But thank you for watching, and we'll see you in the next one. Bye bye.